Hello, I'm Chris King. I'm the Plant PAX Migration Business Development Manager. We know users today have challenges when they have to go from a legacy system and move it over to a modern DCS such as Plant PAX. We have a lot of chance for improvement, and what I'd like you to do is think about what improvements you could have if you changed your legacy system to a new modern system and all the things it could bring for you. For example, you could have 5% more production. You could have 20% less unscheduled downtime. You could have 50% less safety incidents that happen in the plant. You could have 25% less spares needed because you have a brand new system. Those are some of the things I want you to think about while we go through this presentation. So to that end, today I've got with me Paul Wenzel. Paul is our Global Process Technical Consultant, and he is an expert with the Bailey migration options that we have. So Paul, as we know, users that have Bailey systems today are having some challenges in making them work well and having issues. So I'd like to have you take us through some of those challenges that customers have and how you can mitigate those risks and pains going over to a new system.
Certainly. When you replace an old control system with a new control system, you always have the option of doing a rip and replace. What that means is going in and actually taking out the old control system and bringing in your new control system and starting up from scratch. That, of course, requires a lot of downtime, and with that, a lot of loss of production. Many facilities can't really absorb that loss of production, so they would prefer a phased-in approach, where you coordinate your shutdowns or your replacements, your migrations to line up with scheduled shutdowns for maintenance, for instance, and you just migrate a little portion at a time. We at Rockwell have created a number of tools and strategies to reduce those production losses and in fact make it easy so that you can piece by piece migrate to the final control system. Let me show you what I'm talking about. So here we've got a setup with a number of pieces of equipment. At the very bottom we have a Plant PX operator workstation. Right above that we have a Bailey control system, or at least the basics of the Bailey control system. It is a single rack, but it includes both a PCU and a CIU. The PCU, of course, has its communication modules, and it has a controller with its associated I/O cards. This allows the controller, which has all the control strategies, to control devices in the field that are attached to these I/O cards. As we move further to the right, we have our CIU, or Computer Interface Unit. What the Computer Interface Unit actually is a foreign device interface that Bailey uses for all of its devices that it connects and wants to communicate to its controllers with. So when I'm talking about foreign devices, I'm talking about operator workstations, engineering workstations, historians, also the real-time data servers. But most importantly, and what we're going to talk about today is, as some of our tools, is it also allows us to connect an OPC server. As we move over to the other side of the panel, we have the rest of the Bailey equipment. These are field termination units. This is where the actual field devices are terminated to the Bailey equipment. To get the information to the controller, there's these pre-built cables which are routed to the back of those I/O cards so that the controller can actually control the final control devices. Above that, we have an OPC server. This is a unique OPC server to Rockwell in the sense that it's rack mounted. It is hardened in the sense that it's got the same environmental specs that you would expect from a Control-Logix controller. Now, not only do we have the rack-mounted OPC server, but we also have a PC-based server. There are advantages in using a PC-based OPC server or rack-mounted, depending on your situation, but for today, I'm going to concentrate on talking about the rack-mounted one because that's what we have here. So if you think of how a Bailey controller operator workstation works, typically they have a real-time data server which attaches to the CIU and provides that information up to the operator workstation, which populates graphics, faceplates to allow operators to monitor and control the final control elements. We do a very similar approach. So instead of using a real-time data server, instead what we use is an OPC server. And we attach that to the CIU. Then we bring that information into our operating workstation to, again, just like Bailey, display and monitor the control information. So Chris talked about phased approaches. Our first phase, what we call phase 1, is to actually replace all of the operator workstations. And we do just what I was talking about, where we use our OPC90 instead of the Bailey real-time data server and our operator workstations to do that migration. Now the nice thing is, we can connect to a given CIU that's already in place. We do not have to take any downtime. We can do this on the fly. So there's no loss of production when we do it. And in addition, our operator workstation will work in parallel or in concert with the existing legacy control systems or operator workstations. So I'll give you an example on our operator workstation down here. Here we have a graphic which displays some tags or information that's actually in the controller within the PCU. I can simply click on a particular station, and this would correspond with a Bailey station block, which is an interface to a PID. From this faceplate, I can change the mode from Cascade to manual, back to Cascade. I can make all the operations that's required to control this system. Now you might think there's an awful lot of effort if you were to create or recreate the Bailey tag database to an OPC database if you were to do it manually, and it'd be a lot of opportunities to make errors. But we do have a tool that will convert an exported Bailey tag database simply and quickly and accurately to an OPC database that can be promptly downloaded to our OPC server. That is how we do a Rockwell replacement of a Bailey operator console. Now when we look at controllers, we have a specific tool that allows us to mitigate risks and save time when you're actually changing that controller. Here again are the Bailey termination units. These are wired to field devices. We do not have to change any of that wiring, so you don't have to risk disconnecting those wires and reconnecting them. Instead, what we can do is remove the cables from behind the Bailey I/O cards down to these termination units and replace them with our custom cables, Rockwell's custom cables, which will connect those same termination units up to our I/O cards, allowing us to control those same field devices with the Logix controller. This is a graphic depicting what's going on this system right now. On the left-hand side, we have a representation of a Bailey operator console. On the right-hand side, we have a representation of a Plant PX operator workstation. You can see that the one that is active is highlighted with green lines or green icons going up to the left-hand side. What that means is that the termination units are actually wired to the Bailey I/O cards, which talk to its controller and goes to the CIU to OPC to populate this actual screen. And that is shown just by simply squeezing this bulb. You can see sort of a choppy increase in the level with the pressure when I squeeze that bulb. That is just really to show that it is going through the Bailey system. Bailey uses a unique exception report system where the value has to change by at least 1% before it will send that information across to the loop, to the CIU, to the operator workstation. Now, if I want to reduce the time of converting that Bailey controller over to Rockwell, I don't have to rewire all that field wiring. What I can do is remove the existing Bailey cables from the termination unit, and reconnecting these customized cables, which provide that information up to the Rockwell I/O cards to its controller. So now you can see that highlighted on the right-hand side where the information is going over to the Plant PX operator workstation. Again, if I squeeze the bulb, we see a smoother transition as the level goes up and goes down. So it's not using exception reporting, it is truly going through the control Logix or the Rockwell controller. So that is the other tool that we have for doing phase 2. And you selectively go through, replace Bailey controllers. Now there's another thing you have to think about. If you have, this is a very simple Bailey system. It only has one controller, but it's quite likely that a Bailey installation has a number of controllers. And there might be a lot of communications between those controllers. We still have to maintain that communication if we selectively remove one of those Bailey controllers and replace it with a Rockwell controller. And again, we will use either of the OPC servers to maintain those communications so that when you start up, you will have everything running as it should. So that's phase 1 and phase 2 of doing a migration. There, of course, is another option. Instead of doing a phase 1 and phase 2, you can selectively choose, say, an isolated area in your facility, and you can replace it all the way up from the control system all the way up to the operator workstation. The benefit of doing that is you get the immediate benefit of using Rockwell's library and its tool set, which is much stronger from a troubleshooting point of view and maintenance point of view. So anyway, hopefully that gives you a good idea of the tools that we have to mitigate risks and make a transition very quickly in a phased approach when migrating a legacy Bailey control system to Plant PX. Chris, that's really about it. Do you have anything to add?
Yeah, well, thank you, Paul. Appreciate that. I think it's important to note here that we've got some really interesting and sometimes unique solutions that help people move from a legacy system over to Plant PAX. So what I'd like you to think about is if you had one chance for improvement in your existing old system that you could change moving into the new system. So some examples of that might be, you might have 5% more production available. You might have 20% less downtime that's unscheduled. You might have 50% less safety problems in the plant, or perhaps even 25% less spares because you have a brand new system in the plant now. So I'm hoping that you found some interesting ideas here to help you with your modernization path moving forward, and I want to thank you for your time.